Good morning to all. Today the concept is Poisson function. The Poisson distribution is the discrete probability distribution of the number of events occurring in a given time period. Given the average number of times the event occur over that time period. Here the Poisson functionality is nothing but, so it is mainly used in an counting type of applications. Wherever counting is there, so there this function will be used. Poisson density function. Poisson probability density function for a discrete random variable x is given by fx of x is equal to u power of minus b summation k equal to 0 to infinity b power of k by k factorial del of x minus k. So where b is greater than 0 is a real constant. So this formula represents the Poisson density function. Poisson distribution function. Poisson distribution function for a discrete random variable x is given by fx of x is equal to u power of minus b summation k equal to 0 to infinity b power k by k factorial into u of x minus k, where b greater than 0 is a real constant. So here this function represents the Poisson distribution function. This formula represents the Poisson distribution function. Poisson distribution function is the approximated function of the binomial distribution. So where when n tends to infinity and p tends to 0, here the constant b equal to n into p. If the time interval of interest has duration t and the event being counted are known to occur at average rate lambda and have a Poisson distribution, the b is given by b equal to lambda into t. So here a Poisson distribution function is nothing but binomial distribution function, but in Poisson distribution function you are going to be keep n tends to infinity, and here there won't be any success or any failure. Therefore I have been represent p tends to as a 0. So plots of the Poisson's function. So this plot represents the Poisson density function and this plot represents the Poisson distribution function. So Poisson distribution function, anytime it will be in the form of unit step, and density function it will be in the form of impulse. So it is going to be defined only at a particular point. So applications, it is mostly applied to counting type problems. It describes the number of dinners in a certain restaurant every day. If the average number of dinners for every 7 days is 500, you can predict the probability of certain day have more customers. So wherever counting type of application is available, their Poissons will be used. Second one, the number of telephone calls made during a period of time. The number of telephone call made during a period of time. So here we can also be, so in a particular from 10 to 11, so how many calls have got to a particular phone. Number 3, the number of defective items in a given samples. So whenever in a particular factory, so it is going to be prepared some products. So after releasing, so how many products are there detect? So there also will be defect. So how many products are in the form of defect? So here also we will be use the counting type of applications. Number 4, the number of electrons emitted from a cathode in a given time interval. So how many electrons have been emitted from the cathode in a given time interval. So here mainly, so within the time interval how many electrons have been released from the cathode, it also be counting type of mode of applications. Okay, so in this section, so we have been studied so what is meant by Poisson function and what is meant by Poisson density function and Poisson distribution function and applications of the Poisson. Okay, and thank you.